Let's see the part 2 of current electricity. Part 2 of current electricity. So fifth question. Next question is fifth one. The color code of the resistance is given below. So the resistance which is made up of different color. So this is containing yellow. Next one is violet. Next one is violet. After brown. Next is gold. So yellow color. So this is made up of yellow color. Next is violet. So this is your yellow. Next is violet color. So how it looks violet color? This is your violet. Next one is made up of brown. So how it looks? This is your brown color. Next one is gold color. So gold color is like something like this. So this is your gold. Right. So the value of resistance and tolerance, you have to tell it. So let's see the explanation. As we know, yellow has value 4. Similarly, for violet, it is 7, and for brown is 1. So tolerance for gold we know that is 5%. So then resistance will become now 47. So this will be the value 47, right? And this will be the value in the power. So it will be 10 raised to 1, right? Yellow, violet, right? 47 10 raised to 1 plus minus 5%, right? So it will be how much? It is 470 plus minus 5%. So this will be the answer for that. So please write it down. Let's see the question number 6. The relation between sixth question is the charge particle having drift velocity. So charge particle having drift velocity is given, that is 7.5 into 10 raised to minus 4 meter per second, right? In the electric field of velocity is given. So electric field is given, that is 3 into 10 raised to minus 10 volt per meter, right? V for volt and M for meter, right? Has the mobility in. So you have to tell it about mobility. So mobility is nothing but its unit is given meter square per volt per velocity per second, right? So it is asked in 2020. So see the explanation. So you have to find the mobility. So as we know the mobility relation, mobility is represented by mu. So it is given by drift velocity by electric field. So we know the value, it is given in the question. So put the value drift velocity. So this is your drift velocity. So put here, that is 7.5 into 10 raised to minus 4 meter per second divided by electric field. So this part is your electric field value. So it will be 3 into 10 raised to minus 10 volt per meter, right? So your answer will become how much it is coming out. It is 2.5 into 10 raised to 6. This meter multiply with this one. So it will become meter square per volt per second, right? So this is the answer for mobility. So let's see the next sum, that is 7. So seventh is talking about which of the graph represents the variation of resistivity. Resistivity, rho stands for resistivity with the temperature. Capital T stands for temperature. So how resistivity is varying with this resistivity? For the low temperature graph will be a straight line for the metal. So write this statement. At low temperature, graph will be not a straight line for the metal at low temperature. Graph will be straight line for metal. So how it is looking like? So it will be like this only. It is starting from some intercept and increasing inversely. So it is the graph between resistivity versus temperature. Right. Now see the next sum. Next sum is solid which have the negative temperature coefficient of resistance. So it is talking about negative temperature coefficient. Negative temperature coefficient of resistance R. It is asked in 2020. So let's see. At one temperature coefficient of resistance is negative for semiconductor and insulator. So for which it is negative? It is negative for semiconductor material like silicon, germanium, conductor, and for insulator also. Insulators also. Right. So semiconductor example is silicon, germanium, and insulator is like wood, plastic. For them, they are negative, right? So answer will be insulator and semiconductor. It is asked in 2020. So let's see the next one, ninth one. Ninth one, for which the circuit shown in figure current will be. So circuit is given like this. So there is resistance, right? So now there is more resistance connected to it. Current is passing through it, I, and resistance is 4 ohm. This is 2-volt battery, 1 ohm resistance. This is again 4 volt. This is 1 ohm, right? So you have to find the value of current. Everything is known, voltage is known, and resistance is known. You have to find it, the current through it, passing through it. So let's see by applying Kirchhoff voltage law, applying Kirchhoff's voltage law, Kirchhoff's voltage law, right? So suppose I am taking the direction like this. So this is plus minus, this is plus minus, plus minus. So second terminal will take, right? Plus minus, right? So second end will be taken out or written. So see, for the first ohm, we will start from here. Then this is plus, this is minus, right? So it will be minus of 4I, right? We know V equal to IR. So I is current, R is resistance, right? So resistance is 4 multiply with the current. Then again comes minus this value. So it will be minus of 1I. Next is plus, and for battery will take the positive terminal. So it will be plus 4. Then again minus 1. Then plus 2. So two voltages are there. So I will take it as a positive, this part. So I have written here plus 4 and plus 2. And it come to be out to be equal to 0. Right. Now we know the value and we have put on, right. So add these three values. So it will be how much? minus of 6i plus 6 equal to 0. Then it will become 6i equal to 6. So I will be how much? It is equal to 1. So I equal to 1 ampere. Applying Kirchhoff's second law. Right. So this is asked in 2020. Now see the next sum, that is 10th. 10th is two solid conductor are made up of same material, have same length and same resistance. Two conductors are given, right? Suppose this is your conductor 1, this is your conductor 2, have same length, right? And same resistance value. So this is also R, this is also R. One of have a circular cross sectional area, that is A1. So its area is A1 and that of the one is A2. So A2 is your square cross sectional area and this is your cross sectional area. So you have to find the ratio between A1 and A2. Ratio of the resistance. It is asked in 2020. So see, R, rho and L are same for both the conductor. Area will be the same. As we know the formula R equal to rho L upon A, right? So for suppose I am applying this for the first. Similarly for the second one. So I will write here A1. This will become A1. Now for the second one, resistance is same, resistivity is same, length is same. Area is A2 we are taking, right? So this R and this R will get cancelled. Rho cancel, length cancel. So it is coming out to be A1 by A2 is equal to nothing but it is 1. So it should be equal to same, right? So area will be same also. It is asked in 2020. So which formula we have used? Resistance formula. So remember this formula. Next one is 11th one. So let's see. It is asked in 2019. So 6 similar bulbs are connected as shown in figure with DC source of EMF E, zero internal resistance. The power consumed by the bulb all are glowing in the situation when section A and B. So your circuit diagram is like this. Right. So you have to find the value now. So let's see. So applying the second condition where all the bulbs are glowing. So these are the bulbs given. So equivalent resistance will be what? For this. Suppose I am finding equivalent for this parallel 3 resistance. So it will be 1 upon R equivalent 1 is equal to 1 upon R plus 1 upon R plus 1 upon R. Right. So it will become 3 by R, 1 upon R equivalent. So then it R equivalent will become R upon 3. Right. Now for the second parallel condition, suppose I want to find this one, this part. So it is also equal to R. Then 1 R equivalent is equal to 3 upon R, right? We are adding these 3 value reciprocally because it is parallelly connected. Parallelly connected. So in parallelly, we add resistance inversely, right? So it will be coming out to be R equivalent 2 is equal to R upon 3. Now, after that, they are connected in series. So this value is coming out to be R by 3. This is also R by 3. So in series, what we do, we directly add the resistance. So RS will be equal to RE1 plus RE2. Then it is coming out to be R by 3 plus R upon 3. Then it will be 2R upon 3 RS, resistance in series. So this will be the value, right? Now see the next part. Next part is you have to find the initial power, right? Power. So power formula we know, that is E square upon R equivalent. Then it is coming out to be E square R equivalent we have got right now, that is 2R upon 3. So this 3 will come in this numerator. Then it will be 3E square upon 2R, right? So this is the first condition we have solved. Now look at the second one. So when two section A and A, one from the section B are glowing, right? So in this condition, these two bulbs are glowing and one bulb is glowing from here. So your circuit will be reduced like this. It will be like this, right? Two from the first section and one from the second part. This is R, R, R. So this R equivalent will be what? It will be R equivalent to 1, 3 is 1 upon R plus 1 upon R. So add it. So it will be 2 upon R, 1 upon R equivalent 3. Right. So R equivalent is nothing but it is R upon 2. And equivalent of this is connected with this in the series. So it will be again reduced to R by 2 plus R. Right. So R total equivalent in the series will be. So it will be R upon 2 plus R. So answer is coming out to be 3R upon 2. Right. We are taking here LCM. So again, we want to find the final power. So final power is, this is your initial power. Right. This is your final power. So it is nothing but it is power formula we know, that is E square upon RS2. So put the value. So you will get E square upon 3R by 2. So answer will be 2 E square upon 3R. So this is the answer for that. Now we have to take the ratio between the powers. So divide. So initial power divided by final power. So initial power is this one. This is 3E square upon 2R. Final power is this part. So it is 2E square upon 3R, right? So this E square and E square will get cancelled. Right, this is getting cancelled, R is also getting cancelled. Now this will multiply and this will multiply. So it will become 3 into 3 divided by 2 into 2. So it is 9 upon 4 answer. So this is the ratio between the initial and final. Now look at the question number 12. So which of the following acts as a circuit protection device? Circuit protection device, right? So first option is insulator, then switch, fuse, conductor. It is asked in 2019. So fuse acts as a protective device. So it's act as a protective device. Protective device. Because of low melting point of the wire that can save other devices on heating, right? So how it protects? Due to the low melting point. Low melting point, right, of wire, so that it can protect the other devices. So that they can protect other device. So now see the next part, that is 13. So in which of the following device ED current effect is not used? So it is talking about ED current. So ED current effect is not used in the case of electric heater. So where it is not used, it is not used in electric heater, right? Because it works on Joule's heating effect. Because it works on Joule's heating effect. Heating effect. So now see the next part. That is question number 14. So 14 is telling about like a carbon register. Carbon register. So value is given, that is 47 plus minus 4.7 kilo ohm. Right. Is to be marked with ring of different color for its identification. It is asked in 2018. So let's see the explanation. So this is your R value given. So it can be written like this. So it will be nothing but it is 47 into 10 raised to of 3. Already given, kilo means 10 raised to 3. Right. Plus minus of 10% ohm. 1K stand 10 raised to of 3. Now see. So as per color code, as we know, 3 means orange, right? It is nothing but it is orange, right? And 4 means yellow and 7 means violet. Before this, we have solved the similar color, right? And tolerance is given, that is 10%. So it comes under the silver, right? It comes under the silver. So we show the color code. So color code will become then 4 for yellow, right? So I will write here in next step. So it is y equal to 47 into 10 raised to a 3 plus minus of 10% ohm, right? So 4 is nothing but it is yellow, 7 for violet, and tolerance is 10, right? Yellow, violet. Next is tolerance is 10 raised to 3. So it will be orange. Next is silver, right? Due to this 10%. So please write this explanation. Now see the question number 15. So 15 question is, it is asked in 2018. A set of n equal registers. N equal registers are given of value R, right? Each value is R. Are connected in series to the battery of EMF. Connected in series with the battery value E. It is given E. Symbol is U. And internal resistance is also R. And this is the external resistance value R. External resistance. Next one is internal resistance, that is R. Right. The current I is now N resistors are connected in parallel with the same battery and current drawn is from 10 ampere. So the value of R we have to find. This is more about series. Now see the next condition given for the parallel. So N resistors are there connected in parallelly, right, to the same battery. Same battery, right? And current drawn is how much? It is 10 ampere. So it is asked in 2018. So let's see. So when they are connected in series for the first condition, so R total will be R plus R plus R, like that n times. So it will become NR. So this is the value, total value of resistance. So it will be NR, and current for this will be I equal to V upon R. So it will be E upon R plus NR, right? Why it is small capital R? Due to the internal resistance of the battery, right? Now for the parallel, it is R equivalent will be 1 upon R total is equal to 1 upon R plus 1 upon R, like that n times. So it will be equal to how much? It will be n upon R, right? So as we know, current is given by E upon R plus R upon N. So here R total has become how much? R total is nothing but R upon N. So I have put here value R upon N, right? So now we know the value in parallel. So it is 10 ampere. So I will write here 10 ampere is equal to E upon R plus R upon N, right? Take the LCM, then you will get N E upon NR plus R, K9. So we know the condition from the first equation. Series connection, his value is this now. So from this one, put in the second part. So see this. So this is from there, right? So it will be how much? It will be 10I equal to, it will become N into I. So this I and I get cancelled. So N is coming out to be 10. So total 10 resistors are connected, or current increases 10 times, right? In the parallel. So this is the explanation about it. Now look at the question number 16. A battery consists of variable number n, right? So there is battery whose variable resistors are given, whose value is n of identical same, which are connected in series. The terminal of battery are short circuited and current is measured. The value of the graph between them are shown. So see, the given battery variable is n of identical same, internal resistance R connected in series. So current will be given as I equal to NE upon NR, right? So it will become E upon R, right? So option C is correct. So it is the, it is not depends. So current doesn't depends on N, right? So it is not depending. So you can write here I is independent of N. So it is coming out to be the constant, right? So your graph will be like this. So this is the value given to it. It is asked in 2018. Now let's see the next sum. Right. So that's all for the current electricity.